Assalamu alaikum. Chapter Direct and Inverse Proportions, Exercise 1B, Part 1. Topics to be discussed are other form of direct proportions, Exercise 1B, Question 1, 2, and 5, and Practice Exercise 6. For reference, we are using Exercise 1B of this book, so stay tuned.
Other form of direct proportion, y is equals to 3x square. X and the corresponding value of y and y upon x, which is rate, are given as, we can clearly see that when the value of x is increasing, y is increasing, but there is a difference that in each column rate is different. Like in the first column rate is 3, second is 6, third is 9, and fourth column it is 12. So it keeps on changing. Now let us plot a graph between x and y to further investigate these values. Okay, this. So we can clearly see that a curve is formed, right? And we can say that y is not directly proportional to x. Why? Because of three reasons. Number one, it's a curve. Number two, it does not pass through the origin. If you further extend this curve, you can clearly see that it does not pass through the origin. And number three, in all the cases, in all the columns, the rate is not constant. See, the rate is not constant, which means that it does not comes under our definition of direct proportionality. That is, if y is directly proportional to x, then the graph of y against x is a straight line that passes through the origin. Plus, instead of that, if you plot a graph against y and x square, you can see a straight line in a graph, alright, which passes through origin, and in all the cases of y upon x square, that means rate is constant. So we can say that our y is directly proportional to x square, not x. So again, we can say y is not directly proportional to x. Why? Because y upon x is equals to 3x. That means there is a variable in the value of the constant, and when the variable comes, that means it's not constant. However, y is directly proportional to x square because y upon x square is 3 in all the cases. So, which is constant, 3 is constant. So, we can say that y is equals to 3x square. So the question is practice now, part 1. It says if y is directly proportional to x square, let me write down the relationship as y is directly proportional to x, oh sorry, if y is directly proportional to x square, now algebraic expression for direct proportional relationship is kx square, let's call it 1. So if y is directly proportional to x square and y is equals to 18 and x is equals to 3, find an equation connecting x and y. So for any equation we must know the value of k. First we have to find out the value of k. And how will we find out the value of k? We will find out the value of k by using the given values, that is y is equals to 18 and x is equals to 3. I will put these values in our equation number 1. 18 is equals to k into 3 whole square. We can see that here it's y is directly proportional to x square and the value of x is given to us. Okay, so the value of x is given to us, that is 3. So we have to put the value of x in our expression, and 18 is equals to k into 3 into 3 is 9. Now the value of k is 2. For equation now we know the value of k and we will put this value of k in our equation number 1 and we will get the equation that will connect y and x. So y is equals to, the value of k is 2 and it's x square. This is the equation that connects our variable x and y. Part 2. Find the value of y when x is equals to 5. So find the value of 5, part 2. It's very easy. I'm doing it quickly. Y is equals to what when x is equals to 5, and we already know k is equals to 2. So our equation 1 will become y is equals to 2 x square. Now the value of x is 5. I'm going to put this value in place of x and square it. So y is equals to 2 multiplied by 25. That's going to be y is equals to 25 multiplied by 2 is 50, and that's the value of y in this case. Now part 3, calculate the value of x when y is equals to 32. Simple. We don't know the value of x, but we know the value of y is 32, and our constant of variation is 2. Now our equation 1 will become y is equals to 32 is equals to 2 into x square, and 32 divided by 2 is 16, so x square is 16, and here it says that we must know the value of x, not the x square. The value over here is given, the value of x square is the value that we have calculated. Now for the value of x, we will take a root on both the sides. So the square root of 16 is, we all know it's 4. We have learned in the previous class. So this is x is equals to 4. We have to draw the graph between y and x. So first we have to know the values of x and y, the points on which the graph has to be plotted. So remember what we talk about, the direct proportion relationship, that when x and y two variables are in direct proportion relationship, they must pass through the origin. So first if our x is 0, y will be 0. X square is 0, y will be 0. Now if x square, or maybe if x is 1, let's say, what would be the value of y? Okay, so I'm just going to put the value of x and our constant, that is 2, in equation number 1 to get the value of y, the second point on our graph, to get the line of y is equals to 2 multiplied by 1 whole square is going to be 2. So when x is 1, the dependent variable will be
Question number 1,
2.
4, 2, 3 and 5 can be done with the similar method. So please follow the following steps.
Thank you for watching. Subscribe for more updates.